Welcome back to Carneades.org. Today we're going to be continuing with an intergalactic obliteration of the cosmic fine-tuning argument. In this video, we're going to be looking at the confirmation fine-tuning argument and Bayesian epistemology. So this argument is going to be kind of a weaker version of the original cosmic fine-tuning argument, saying that cosmic fine-tuning argument doesn't necessarily prove God, but it provides some confirmation or some reason we might believe in God. So, some theists find some of the objections to the structure of the cosmic fine-tuning argument persuasive. However, they don't think that this is grounds for disregarding it altogether. In fact, they claim that the observation that the universe exists and is fine-tuned is evidence that confirms the hypothesis that God exists, that doesn't necessarily prove this hypothesis. One such philosopher is Robin Collins, who avers that the principle of prime confirmation is the case. The prime principle of confirmation is the case. The principle can be stated as follows. Given two hypotheses, H and H2, and one observation, O, if O is more likely given that H, then O confirms H. Let's compare this to Bayesian confirmation because there's going to be some interesting similarities. So, given two hypotheses, H and H2, and one observation, O, if O is more likely given that H than O given that H2, then O confirms H. Evidence E confirms theory H if and only if our degree of belief in H is increased if E is known. Or in other words, E confirms H if and only if the probability initial of H is less than the probability of H given that E. Note the difference between these two versions of confirmation. For the Bayesian, E confirms H if H is more likely given that E than H's original probability. For Collins, O confirms H if O is more likely given that H than the probability of O given that H2. Here's an example that'll kind of help you contrast the two claims. Take H as the theory that Geoffrey the Greyhound will win the race. Take H2 as George the Greyhound will win the race. And take E, or O in the case of Collins, as that you saw Geoffrey's trainer giving him performance-enhancing steroids. So, for the Bayesian, Geoffrey getting steroids would confirm his chances of winning, if and only if he has a better chance of winning with the steroids than he does regardless of steroids. If, looking at given that E, his chance of winning becomes better than his chance of winning regardless of steroids. For Collins, on the other hand, Geoffrey getting steroids would confirm his chances of winning if it is more likely that he took steroids given that he won than given that George won. So looking at the hypothesis that Geoffrey wins, is it more likely that he took steroids or not, compared to the hypothesis that George won, is it more likely that Geoffrey took steroids or not? It's interesting to note that if H2 is in fact the same as not H, then these two types of confirmation are actually going to be identical. To show this, we need to show that when one confirms, the other does, when one disconfirms, the other does, and when one neither confirms nor disconfirms, the other does as well. Note that we're not necessarily going to want to adjust our probabilities in the same way, which is going to make Bayesian epistemology very distinct, but these theories are still going to offer the same question of confirmation, disconfirmation, or neither confirms nor disconfirms, as long as H2 is the same as not H, or in other words, H2 offers all of the other alternatives to H. So, to prove this, we'll offer just one quick proof, and then you can do the rest of them on your own because the method is going to be identical. So assume there exists a case in which Bayes will confirm but Collins will not. This same method can be used for Bayes will disconfirm but Collins will not. Collins will disconfirm but Bayes will not. Bayes will neither confirm nor disconfirm but Collins will either confirm or disconfirm, and so on and so forth. So, assume that Bayes confirms. The probability of H and E over the probability of E is going to be greater than the probability of H. and assume that Collins will not confirm. So the probability of H and E over the probability that H is less than or equal to the probability of not H and E over the probability of not H. Those are both our assumptions. Now we're going to look and see if those two assumptions lead to a contradiction. If they do, then we've shown that if Bayes confirms, Collins must confirm as well. So it's a given that the probability of H, or rather not H and E, is equal to the probability that E minus the probability that H and E. It's also a given that the probability of not H is equal to 1 minus the probability of H. We can then go ahead and take our statements 2, 3, and 4 and substitute in for not H and not H and E to get the probability of H and E over the probability of H is less than the probability of E minus the probability of H and E over 1 minus the probability of H. Then we can go ahead and cross-multiply those two statements because we know none of our probabilities are going to be negative. Our greater than sign or less than sign doesn't switch directions. So we end up with the probability of H and E times 1 minus the probability of H is less than the probability of E minus the probability of H and E times the probability of H. We'll then go ahead and distribute those terms, so we get the probability of H and E minus the probability of H times the probability of H and E is less than the probability of E times the probability of H minus the probability of H and E times the probability of H. Looking at those two statements, we see very clearly that we have a negative probability of H times the probability of H and E on both sides. We can just get rid of those two by adding the probability of H times the probability of H and E to both sides, which gives us the probability of H and E is less than the probability of E times the probability of H. Then all we need to do is divide both sides by the probability of E to get the probability of H and E over the probability of E is less than the probability of H. This is clearly a negation of our original first assumption. Therefore, between 1 and 9, we end up with a contradiction. So whenever Bayes confirms, Collins must confirm as well. Once again, you can do this for all the cases of confirmation, disconfirmation, and neither confirm nor disconfirm if you want to, but it seems that they're all going to work out nicely. So as long as H2 is the same as not H, Bayesian confirmation and Collins' prime principle of confirmation are just going to be the same, though stated differently. So now on to the confirmation fine-tuning argument. So take the following two hypotheses. The design hypothesis, there exists a universe which was finely tuned to sustain life by a God that exists. And the chance hypothesis, one universe exists which came to be finely tuned for life by chance. The observation or evidence that the universe is in fact fine-tuned to sustain life is more likely given the first hypothesis than the second. Therefore, fine-tuning confirms the existence of God. So, if the only way we could arrive at fine-tuned for life constants is by extremely unlikely chance or by design, certainly if the design hypothesis is the case, the finely tuned constants are almost assured. But if the chance hypothesis is the case, then the finely tuned constants were very, very unlikely. So we're confirming our first hypothesis about the existence of God. For the Bayesian, the design hypothesis is also going to be confirmed, but just in the case that either you claim that the chance hypothesis is the only alternative, therefore making H2 equal to not H, and leading us back into the proof we just showed, or you consider the design hypothesis more likely upon discovering that the universe is finely tuned. And the fact that the probability of H initial is less than the probability of H given that E. Basically, for Bayesian confirmation to work, either you have to say that the chance hypothesis is the only alternative, or you have to say that the design hypothesis is going to be more likely when you discover that the universe is fine-tuned. Basically, the design hypothesis is going to increase in degree of belief when you find out that the universe is finely tuned. So that was the confirmation fine-tuning argument. Next up, we're going to look at the problem of the priors for fine-tuning, which is going to be a very specific objection to the confirmation fine-tuning argument, if you know anything about Bayesian epistemology and the problem of the priors. Then we'll talk about Ed's perfect design, which is just going to be a general objection to the cosmic fine-tuning argument. And finally, cosmology is not science, which of course is another general objection to cosmic fine-tuning and, in fact, cosmology as a whole. Watch this video and more here at Carneades.org, and stay skeptical, everybody.